Good morning, ladies and gentlemen. This is section 8.5 and 8.6 of Mrs. Quinn's geometry. And today we're going to look at areas of polygons. Oops. We'll be doing 8.5 and 8.6. First of all, with any polygon, we can do something called triangulate it. And that means that I can separate it into multiple triangles. You can see I have a triangle here, here, and here. And the way we come up with the formulas for our areas of polygons is oftentimes through finding the areas of our triangles. And I'll show you that here in just a minute. If you look at this area of a trapezoid, we could draw a triangle here and a triangle here. Maybe I should do that in a different color. Notice that I have a triangle here and a triangle here. If I triangulate it, I could find the area of this triangle, which would be 1/2 base 1 times my altitude or my height. And then if I find the area of this triangle, I would get 1/2 times the base 2 times the altitude or the height. Notice that the height is the same for both. And we could factor out 1/2 base times height, or the 1/2 height. And in this first term, we have base 1. And in the second term, we have base 2. So oftentimes, the way we find these formulas is through knowing the rules about triangles. I'm not going to require that you know how to do that, but I am going to require that you know how to utilize your formula. So let's go ahead and utilize the formula. If I'm looking at this trapezoid right here, and I want to remember I have 1/2 height times base 1 plus base 2. And I'll just plug into my formula. My altitude here is 6. My base 1 is 4. And my base 2 is 12. 1/2 times 6, we can go ahead and simplify that to be 3. And 4 plus 12 is definitely 16. When I multiply these two together, 3 times 16, hopefully I get 48. I'm using meters, so my final solution should be meters squared. All right, let's talk about the area for a parallelogram. Your parallelogram area is simply base times height. So let's try that formula. If I'm looking at the area of this parallelogram right here, I have base, which is 20 inches, times height, which is 18 inches. Oops. Now, oftentimes we don't put the units in until we're done, but let's just go ahead and make note that 20 times 18 is 360, and it's the fact that I have inches times inches that I get inches squared. All right, now we've tried both formulas. For tomorrow, you're going to have 2 video questions. This first one is for 8.5. I want you to find the area of the parallelogram using base times height, and find the area of the trapezoid using 1/2 height times the quantity of base 1 times plus base 2. All right, find those 2 areas, and let's go to 8.6. The reason I'm putting these 2 sections together, and we'll do it with a worksheet tomorrow, is because most of us have seen these 2 pieces of information, areas of parallelograms and trapezoids and the Pythagorean theorem. So we're going to stick it together on one worksheet and get it done. All right, let's look at the proof of the Pythagorean theorem. Most of us are already familiar with the Pythagorean theorem that says that for a right triangle only, you have a hypotenuse and you have a base and a height. And we're familiar with the fact that we can say that c squared, my hypotenuse, is going to equal a squared plus b squared. And let's look at a quick example of why. If we have an inscribed square inside of another square, notice that the hypotenuse here that's created with this right triangle is c. And we'll call this length A and this length B and this A. So notice that it's the same for each. So let's find the area of my shaded region in here Let's find the area of this square by finding the area of the big square minus the triangles. Hopefully we're familiar with that technique after doing that section on geometric probability. So the area of this big square is going to be A plus B, this whole side length, times this side length, which is also A plus B. Now when I FOIL those together, I'm going to do first outer, inner, last. Hopefully you did that in Algebra 1. And we get A squared plus 2AB plus B squared. Now, if that is the area of the entire entire square, and I want just the value of the shaded region, I'm going to have to subtract 4 of these. And so I want this area minus, I have 4 triangles that are all 1/2 base times height. So I would have 1/2 base is A times height, which is B, and hopefully you'll agree with me that 4 times 1/2 is 2. And now I have, for the area of the green region, A squared plus 2AB plus B squared minus 4 times 2 is 2, 2AB. Notice that these terms are going to cancel, and I'm going to get A squared plus B squared, which we all agree that the area of this square is going to be side times side. It's also C squared. And that's just an example of how this beautiful theorem works. Now let's practice utilizing it. We have several Pythagorean triples. For example, the numbers 1, 2, and you know what? We've got 3, 4, and 5 are Pythagorean triples, which means that if your hypotenuse is 5, these other lengths will always be 3 and 4. And there's multiple Pythagorean triples, and we'll go over a few more of them in class tomorrow. But this is probably your first example. Over here, I can use the Pythagorean theorem to find missing side lengths. The value of C is always the one directly across from your right angle. So identify your right angle, and directly across is C. So we're going to plug into C squared equals A squared plus B squared. So I'll get 12 squared equals X squared plus 5 squared. 12 squared is 144. 5 squared is 25. And when I subtract 25, I'm going to get what? Hopefully, you agree with me that it is 119. And then when I square root both sides, technically I get 2 solutions. One is a positive and one is a negative. But the only one I want to deal with distance is the positive solution. Because I'm dealing with units, my end answer should be in inches. So let me add that to my answer. That many inches. And for now, let's keep it in radical form. All right, here if I want to find x, your hypotenuse is 20. So you have 20 squared equals, my a value is 3, and my b value is x. I get 400 equals 9 plus x squared. When I subtract 9 on both sides, I get 391. Square root both sides, get 2 answers, but only take the positive one into consideration because we are dealing with distance. Number 2 here, our C value is 16. My A value is X, and my B value is 6. 16 squared is 256. I subtract 36 on both sides, I get 220. And we're going to talk about simplifying our radicals a little bit more tomorrow. I just want you to be able to plug into your formula comfortably. Square root both sides, and we're going to get the square root of 220 meters. All right, now sometimes we're going to use this to find a missing piece so that we can find our area. Hopefully you'll agree from a previous section that your area is going to be your altitude times 1/2 times your base. And so here we don't know what our base value is, but we could find it. The value of C is 45. The value of A is X. And the value of B is 35. So let's go ahead and square 45. And I get 2,025. Let's square 35. And I get 1,225. And if I subtract that on both sides, I'm going to get x squared equals 800. Now, to solve for x, I'm going to square root both sides. I'm only going to utilize the positive solution. And because we're going to work with area, let's go ahead and write the approximate value at this point. The square root is approximately 28.28 centimeters. Now I could find my area. My area is going to be 1/2 my base, my 28.28, times my height, which was 35. So I would have approximately 494.9, and my units should be squared, centimeters squared. All right, for tomorrow, I'd like you to find x and then the area, and I will see you then.